Welcome back to Safety and Civil Engineers Inside. Today, I will put you through how to calculate the materials in concrete using grade of concrete 1 to 4. Now, what do you understand by the word concrete? I'll tell you. Concrete is a composite materials composed of several components such as the cement, the sand, the gravel, and water, and often additional admixture. So in your concrete, we have the composition, as you can see here, we have the composition of cement, sand, the gravel, and water. So what constitutes the concrete is four elements: the cement, the sand, the gravel, and water. So these are the main materials of concrete. Now, let me tell you what cement is all about. Cement is the binding agent in concrete, and the mostly commonly used type of cement is the Portland cement. The aggregate. Aggregate is made up of the bulk of the concrete mixture and provide a structural strength. The coarse aggregate, typically known as gravel or crushed stone, it provides bulk and stability to the concrete. The fine aggregate, known as the sand, which fill the space between the coarse aggregate and help create a workable mixture. The size, shape, and grading of aggregates can be influenced by the properties of this concrete. So you take note, the size, the shape, and the grading of aggregates can influence the property of concrete. So these are very, very important. Then we also have the water. The water here. The water is essential for the chemical reaction called hydration, which causes cement to harden and bind the aggregates together. The water to cement ratio is a critical parameter in concrete. Take note, please, as it affects the strength, workability, and durability of the final product. And lastly, the amount of water used should be carefully controlled to achieve the desirable properties. So when carrying out your concrete mix, you have to take note of the quantity of water you use in order to achieve your desirable properties of this mix. We have the cement, we have the sand, we have the gravel, we have the water. So you have to take note of all this. It's important and it's imperative in carrying out your concrete work. So let's move further. So I will teach you how to calculate the materials in this concrete using grade 1 to 4. We have other concrete grade, but in this course of learning, I'll use grade 1 to 4 as a typical example. So let's move forward. Now, this is a rectangular block of concrete. We have the length here, as you can see, 0.3 meters, the width 0.2 meters, and the depth, or you say the height, the depth 4 meters. So note, from the diagram as shown, the length of concrete block is 0.3 meters. The weight of concrete block is 0.2 meters. The depth of concrete block is 4 meters. Solution. Now, let's achieve the volume of concrete block. What is the volume of concrete block? The volume of this concrete block is 4 the height or the depth, multiplied by the length, and also multiplied by the width. So this is it. 4 multiplied by 0.3 by 0.2, we achieve this figure. 0.24 meter cube. So this is our wet volume of concrete. So let's achieve our dry volume of concrete. So we have a conversion factor, which is 1.54. Converting wet volume to dry volume. So there is it. Dry volume of concrete is equal to 0.24, which is this, multiplied by the conversion factor, which is 1.54. So we get 0.370 cubic meter. Then here, we'll also need to achieve the grade of concrete, which we were using, or we are using 1:2:4. Take note, the 1 is for the cement, the 2 is for the sand, and the 4 is for the aggregate, known as the coarse aggregate, the gravel, your crushed stone. Yeah. So to achieve, let's achieve the total volume of concrete, which is 1 plus 2 plus 4. 1 plus 2 plus 4 is equals to 7. So the total ratio of our concrete is 7. Let's get down to business. Number one, calculating the quantity of cement. So we want to calculate the quantity of cement in this rectangular block. So to do that, we say um, the volume of cement is equals to ratio of cement to concrete multiplied by dry volume of concrete. Now we have 1/7. This one is for the cement. Remember, we are calculating the quantity of cement. So this one represents the cement, which is 1. Then the total ratio of cement, which is 7. You say 1/7 multiplied by the dry volume of concrete, which is 0.370 cubic meters. Thank you. So to do that, you say 1/7 multiply by 0.370 is equals to 0.053 meter cube. So our volume of concrete here is 0.053 cubic meters. Now we need to achieve the weight of cement. To do that, you say the weight of cement is equal to the volume multiplied by the density. So the density of cement is 1,440 kilogram per meter cube, which is this. So we now say the volume of cement, which is 0.053 from here, multiply by the density of cement, 1,440, we achieve 76.32 kilogram. So this is the weight of the cement being used in this concrete work. So this is the concrete work. This is what we want to achieve. The quantity of cement used in this rectangular concrete block work. So we have this from our calculation. We have 76.32 kilogram. Now we are meant to understand that a bag of cement is 50 kg per weight. So approximately we have 2 bags of cement to achieve this work. Where is it? To achieve this work. So we need maximum 2 bags of cement from our estimation. Now let's calculate the quantity of sand known as a fine aggregate. To do that, you say volume of cement is equals to ratio of sand to concrete multiplied by dry volume of concrete. So our ratio here, which is sand, this is sand, which is 2 all over 7. The total ratio of concrete here, you have 7 multiplied by the dry volume of concrete. So this is our dry volume of concrete, 0.370 as calculated earlier on. So we have 0.163 0.106 meter cube. That is our volume of concrete in sand. So to achieve the weight of sand, we have volume multiplied by density. Density of sand is 1,740 kilogram per cubic meter. Now, this is the volume of cement, which is this 0.106, multiplied by the density of sand, 1740, we have 184.4 kilogram. So this is the quantity of fine aggregate known as sand that was used in this work, in this concrete work to produce this size of concrete block. So let's calculate for that of the coarse aggregate known as the gravel. Volume of aggregate equals ratio of aggregate to concrete multiplied by dry volume of concrete. So to do that, we have 4 over 7. You know where this 4 came from? Came from here, 4. So we are dealing with aggregate. So 4 over 7 multiplied by the dry volume of concrete, known as 0.370. We have 0.211 cubic meters. That is our volume of aggregate. Now, to achieve the weight of aggregate is equals to the volume multiplied by the density. Take note, the density of the aggregate is between the range of 1,480 kilogram per meter cube to 2,100 kilogram per meter cube. So you have to choose the range between this. So for this class, I choose 1,650, which is between the range of 1,480 to 2,100. So you now say the volume, which is 0.221, which is this, multiply by 1,650, we have 348.2 kilogram. So that is the estimated quantity of coarse, or you say coarse aggregate, which is our gravel, as we all know, or crushed stone. So this is it for this concrete block work. So to do that, we achieve this estimated figure for that work. So let's go to calculating the volume of water. In order for we to get the right quantity or amount of water to carry out in this work, as we earlier said, we have some little calculations, which is water cement ratio is equals to weight of cement multiplied by the volume of water. Take note, using water cement ratio of 0.5. Therefore, the volume of water is equals to weight of cement multiplied by water cement ratio. Now we are meant to understand that this 0.5 is our water cement ratio, then 76.32 is the weight of cement. How did we achieve that? Let's check it in our earlier calculation. So is here, you see. Okay, so this is our weight of cement, which is 76.32. So in order for we to get our volume of water, we say 76.32 multiplied by 0.5, we have 38.2 liters of water. So to achieve this work, we need 38.2 liters of water for this concrete rectangular block work. So in summary, you can see that to achieve this concrete work, we have cement 76.32 kg. For sand, we have 184.4 kg. Gravel, we have 390 kg. Then water, we have 38.2 liters. So to achieve this, this is all what you need. Then from there, you can now put your prices. How much is a bag of cement? How much is sand? How much is gravel? If you need to buy water, you have 38.2 liters. How much is the cost for a liter? So you do all your estimation and come up with this wonderful and desirable design. So take note, it is important and it is imperative for you to come up with such estimation like this so that it will guide you, not to put you into quagmire or imperil. So you have to take note of that. Thank you for watching. God bless.